Okay, we are going to start talking about angle measures today. With regards to parallel lines and transversals. So, one thing that we need to point out right away is the vocabulary word transversal. And what that means is just a line that intersects other lines. So, the transversal here would be M on page 63. So we're just going to go through one example and kind of hit everything we need to hit here in the one example, and then the problem set numbers 1 through 10 will be the homework tonight. So in this figure below, line 1 is parallel to line 2. That's what these two little lines mean. And M is the transversal. Use a protractor to measure angles 1 through 8. List the angles that are equal in measure. Okay, we're actually only going to measure one of these angles, and we're going to use that one angle to figure out the rest of the angles. Okay, so in a diagram like this, when you have two parallel lines, there are several tricks you can use to find all of 8 angles just by knowing one. So if we start with a protractor here on the line, I'm going to start by measuring angle 2. So if you take a look here and you line it up directly, angle 2 is about 140 degrees. So we're going to label that 140 degrees. Okay, if we know angle 2 on here, we actually can easily figure out angle 1 because angle 1 and 2 lie on a straight line. Well, a straight line, since this is our notes, we'll write this down, is equal to 180 degrees. So if angle 2, this portion of it is 140, to find angle 1, we would subtract 180 minus 140 equals, and I'm going to use another color here because in the end it's going to help us. Angle 1 has to be 40 degrees then. Okay, now this is really all the information we need to know all the way through, because as you go down now, you can figure that out, that 2 and 3 also lie on one straight line. They lie on the transversal. So if this is 140 and this is a straight line, this also has to be 40 degrees, because 180 minus 140 is 40 degrees. And then the same holds true here. 1 and 4 are again on a straight line. So if 1 is 40 degrees, 180 now minus 40 gives you 140 degrees. Okay? And so we have all 4. Now if you slide down the transversal, you have a parallel line here. And since these two are parallel, these two images are corresponding, meaning they are the same. So angle 1 is in the same position as angle 5. Those are called corresponding angles. So since they are on parallel lines and they're corresponding, we know that they are equal, 40 degrees. Same thing with 2 and 6. So 2 is in the upper right-hand corner, and so is 6 down here. They're parallel lines, so they have to be equal. Same with 4 and 8. So we have 140 degrees. And finally, the same with 3 and 7. And when you finish this, you notice there's a pattern there. Okay, so once you know one of them, 40, 140, 40, 140, 40, 140, 40, 140, it will be every other one all the way around the entire thing. Only if these two are parallel, though. Okay, some of the vocabulary now that goes with this was corresponding angles. So what that means is they're in the same location. So for example, angle 1 and angle 5 are corresponding angles. And then transversal, so that would be like an intersecting line there. Okay, so some of the questions you're going to see with things like this look like this. What do you notice about the measures of angle 1 and angle 5? Okay, so angle 1 and angle 5, they are the same, And it says, why do you think this is so? The way we're going to answer this is using our vocabulary, because they are corresponding, and I'm going to abbreviate that, angles on parallel lines. It's important that we include that they are, parallel lines, because if they weren't parallel, that wouldn't work out. What did you notice about the measures of angles 3 and 7? Okay, here's 3, here's 7. Those are also corresponding angles, and they're also the same measure. So instead of rewriting that, we're just going to draw an arrow in interest of time. It's actually the same exact reasoning. They're corresponding angles on parallel lines. Another one is, what did you notice about the measures of angles 4 and 6? Now this one's a little bit different though. So 4 is right here and 6 is right here. And they are also the same. However, those are not corresponding angles. This one's the bottom left and this is the top right. So why do we think this is so? And here comes another vocabulary term. Because they are what we call alternate interior angles. And this is another math term that we are going to need to know. So alternate meaning they're on opposite sides of the transversal. Okay, so if you look at these, 4 is on the left side of the transversal, 6 is on the right. And interior meaning they're on the inside of the parallel lines. Okay, so those will always be the same, alternate interior angles. And the last vocabulary term, which is not on this page unfortunately, and we're going to put it up here at the top, I am, because I don't have enough space, is called alternate exterior angles. And this should be all the information we need to do the problem set on the next page. But what this means, alternate exterior angles, means alternate, again, is opposite sides of the transversal. And exterior means outside the parallel lines. So an example of alternate exterior angles might be 2 and 8, because they're on, 2's on the right side, 8's on the left of the transversal. That makes them alternate. And exterior, 2 is on the outside of line 1, and 8 is on the outside of line 2. They're on the outside of the parallel lines. And those will always be the same as well. Okay, that is the main points of this lesson for lesson 12. And there's more that you can look at to help you out. On page 64, there's a lesson summary here that gives you, again, all of our vocabulary that we just learned, along with a diagram to help you out. The problem set today, the homework will be starting here on page 64. You're going to use this diagram here to answer numbers 1 through 10 on page 65. And that will be due tomorrow. Good luck. If you have questions, please come see me.